Hi, everyone. Here we're going to be talking about input and output devices. We're going to be talking about general and specialized input-output, expansion ports, Bluetooth, device drivers, display device, printers, and autonomous vehicles. Actually, you can see this farther in the book. I'm not going to talk about this here, but you can certainly explore more in the textbook as you wish. Computer input and output devices. So as you probably are familiar with, some devices on the computer, like for example, keyboards and mice, they are input devices. They're devices we use to direct actions to the computer. They're not output devices. They don't bring information in, although of course they may, for example, there might be a little bit of a light, there's like a light on the keyboard. So in a way it does bring in information. It is an output device, but it's mostly input. And many of these can actually be both. For example, scanner. Scanner is an input device, but a scanner is often attached to a printer, which is a printing device. So sometimes this is an abstraction. Credit card scanners, barcode readers, biometric scanners, they're all input devices. Some are input and output fitness trackers people put on their body, wearable devices. They sense information from you, and they also emit output information for you to see and understand. Audio headsets, VR headsets, they're both input and output. Of course, some are just output or mostly output. Speakers, projectors, monitors of this display devices. Expansion ports. Many digital devices have ports in the system board for connecting cables and various add-ons. These ports are called expansion ports because they expand the option for input, output, and storage. When you plug in a USB flash drive and insert a memory card, you are using an expansion port. We had some images before too. You can take a look at those from the Raspberry Pi. Here's a more focused image of these. You have expansion ports. USB is a very common one nowadays because it can transfer all kinds of data and programs, and it's very fast and it keeps getting faster and faster. So a USB is a very general, this is why they call it general purpose port, because you can connect all sorts of other computer gadgets and so on. Some are more specialized, so display devices like VGA, DVI, HDMI, mini DisplayPort. These are all about just for graphics. And usually the ones looking here, they are export. But of course, there's also an import side as well of the graphics in the system board. But these are, the ones that we'll see here for the export. Audio in, audio out. So there's audio in, takes the information in, audio out, emits the information out, the audio. And they usually sometimes these are called like 3.5 millimeter microphone jack or 1/4 inch mic or audio jack. Ethernet is another kind of expansion port or wireless antenna, which may be connected to a USB device as well, a USB port rather. Bluetooth. A Bluetooth is a common wireless technology for connecting peripheral devices like printers and speakers to a host unit. Bluetooth works by emitting and receiving short-range radio waves, frequencies between 2.4 and 2.48 gigahertz. So they're actually kind of fast, but it's for short-range transmission. Bluetooth is low power or relatively low power, so it's ideal for mobile devices. Bluetooth is built onto many devices for short-term wireless connection. So I was trying to even get an image of what a Bluetooth device looks like, but it's kind of microscopic. So it's just like a little antenna, just a little piece of, on the circuit board, you kind of barely see. But that itself is enough to send the radio wave. It's sending radio waves essentially. Some nice little information here on the nature of the Bluetooth logo, which comes from a runic letter, a runic alphabet, the Scandinavian alphabet. And it actually just spells the letters Hagal and Bjarkan put together, which is the for King Harald Bluetooth, the Danish King Harald Bluetooth, and it was named by Intel engineer Jim Kardecka, 1987, and I guess it caught on. A device driver is a software that helps two devices connect with each other. You may be familiar with these when you need to connect a printer. So often for devices to communicate, your printer to communicate with your main computer, you need a little specialized software that creates the connection, creates the communication. And that's usually the device driver. Computers are different. You have Mac computers, you have Windows computers, you have Unix computers, Linux computers, right? You have Android computers. So a printer, usually they have their own operating system and they communicate with other devices via the device driver, because they don't want to just create their own operating system just for one computer. They want it to match to others. So that's why the device driver serves as that translator to connect to various kinds of other machines and operating systems. Display devices. A computer displays a device that simply displays text and images. It's usually an output device, and it's also called a computer monitor or screen. Of course, nowadays we have other touch screen devices which can be both input and output. LCD refers to liquid crystal display, and that's the current popular technology for display devices that works by producing images by filtering light, such as LED light. So LCD can use the LED lights or not, but I think most of them do use LED, and displays this light through a layer of liquid crystal cells. So this kind of LCD technology has, I think, pretty much 100% replaced cathode ray tube, CRT analog technology, which is from the old big computers. So this older technology needed this very big hardware to actually create the images that we see, the vacuum tubes of an electron guns that are shooting at a screen. And of course, this technology has disappeared very fast and has been replaced by LCD technology. Now, some people swear by that this is better, and you can see better images, but it's kind of hard to find these anymore, and I'm not really sure how better they really are from LCD in terms of the image itself. Factors that affect image quality on display devices are screen size, that is the measurement in inches from one corner of the screen diagonally across to the opposite corner, usually in inches. So you see, 14-inch screen, 14-inch screen and so on. So it's kind of the standard screen size measurement that will impact the quality of the image. Response rate, the time it takes for one pixel to change from black to white and back to black. It's something you usually don't see, but sometimes you see listed the response rate of the screen. Now, this measure, of course, is usually the screen size is very obvious, and people need to determine what kind of screen size that they want. Mobile devices are smaller. 14 is kind of a smallish laptop. They have desktop, maybe 15, 20, and plus inches. Screen resolution. The screen resolution has to do with the number of horizontal and vertical pixels that a device displays on the screen. So something like 1080 times 920. Now it goes down really low, like 600 times 800. But these are the number of pixels, horizontal and vertical pixels on the screen. And you can see the pixel is like that little tiny square that you can see on these images on the screen from the raster data. We'll talk more about that later. There's another measure, which is the dot pitch, which describes the distance in millimeters between dots on the screen, which is sub-pixel. So within the pixel, there is the sub-pixel, which is the little dots that you can't really see with your eyes easily, unless some screens you can, but if you really put your face really closely. But these are the dot pitch, and that's another relevant measure to measure the image quality. A little bit more on display devices. So just some representation here of two kinds of technologies of touch screen especially. So tablet computers, handheld device, retail stores, self-checkouts, and ATMs display output and collect input from a touch screen. So this is very common. The screens are not just output, they're both input as well. And they can also display a virtual keyboard for devices or virtual buttons, right? You see the button there on the screen itself, okay or cancel, but are not connected to a physical keyboard. So sometimes they'll have the physical keyboard, sometimes they'll display on the screen itself. Now there are two kinds of screens. So one is called resistive technology, and resistive technology, as the name suggests, is more resistive. So it is more resistive. It's not susceptible to dust or water, but it can be damaged by sharp objects. So it's more durable. Now, capacitive technologies is a little bit different. They contain a transparent panel coated with a thin layer of electric conducive material. And they're very sensitive to the touch. So they're more delicate, but they're more sensitive. So there are things, you know, used for drawing, and these kinds of activities. And they are more sensitive. So they're called capacitive technologies. They're more sensitive to the touch, and they can interpret complex inputs such as handwriting and very detailed drawing. Graphic processing units. So dedicated graphics is a GPU, graphic processing unit, on a small circuit board called the graphics card or video card. As we saw before, sometimes in the microprocessor itself, in the integrated circuit that we saw before, there will be a GPU inside. They will process the graphics inside the integrated circuit itself. However, often there will be specialized GPU. So if you're dealing with more complex video material, you need to maybe consider complex GPU. The GPU is a microprocessor that may generate enough heat to require a cooling fan. So there might be a heat. You can see here, there's a system board, a whole big system board with expansion ports, output devices for the video screens. There's a fan itself on it and so on. So it's a fairly complex piece of machinery. And printers are the very well adored, I guess, output devices that we use to print graphic material. Today's best-selling multifunction printers use inkjet or laser technology and can also serve as scanners, copiers, and fax machines. So just I think an important note here on the difference between the inkjet versus the laser printing. So inkjet printer has a nozzle-like print head that sprays ink onto paper to form characters and graphics. These are generally, and it'll look like something like this. You might have changed a color ink cartridges on a printer. These are usually better for photographs and high quality graphics. And then you have the laser printing, which is kind of hard to tell just from the look, but this is a laser printer. And it works by using a laser beam back and forth over a negatively charged cylinder called a drum to define an image. And you know, this kind of, they use the toner and you change the whole toner itself rather than specific ink cartridges. And these are more economical for text and simpler graphics. So they're faster, they can do more printing than the ink itself. But if you are looking for quality, you go with inkjet. If you're looking for practical text-based and simpler graphics, you go with laser printing. And that's a review of some of the topics we covered. And that's it for this one.